Today, we're going to talk about something really weird. The biggest, most powerful AIs out there have this huge blind spot. But there's a fascinating, kind of radical solution inspired by nature that might just be the answer. So, let's get right into it.
I mean, come on, you've seen it. These massive foundation models, like ChatGPT, they're literally changing our world. The way they can just absorb and spit out information from these enormous data sets, it's just incredible. It's like having this massive library of knowledge that can talk back to you.
Okay, but here's where it gets weird. You take these incredibly smart, general-purpose AIs, and you drop them into a situation where things are changing fast and the stakes are super high, like a hospital's ICU, and they just fall apart. And this isn't some small glitch, It really gets at a deep, fundamental problem with how they're designed. All right, so what exactly is this giant's blind spot? Well, to get our heads around it, we need to talk about a classic problem in data science, one that just goes completely off the rails as things get more and more complex. It's got this really cool name, the curse of dimensionality. Okay, so think about it like this. Every single piece of data about a patient, their heart rate, blood pressure, how a ventilator is set, that's a dimension. In a really complex case, you could have hundreds, maybe even thousands of these things to track. The curse is that as you add more of these dimensions, the amount of data you need to find any meaningful pattern just skyrockets. I mean, it grows exponentially. It becomes impossible to manage. And this is a great way to picture the problem. In a simple world with just a couple of variables, it's pretty easy for an AI to find a neighbor, a similar case from the past, that it can learn from. But in the super high-dimensional chaos of an ICU patient, every single moment is basically a first. The patient's data becomes this lonely, isolated island. And finding a similar case to learn from, it's pretty much impossible. And that brings us to the absolute heart of the problem. These giant models are masters of interpolation. What does that mean? They are incredible at making predictions for things that fall in between the dots of data they've already seen. But what they absolutely cannot do is extrapolate. They can't reason about something genuinely new, something that lies outside of their training data. And in a crisis, when a patient's condition is going off script in a totally new way, well, that's the one thing you need them to do. So, okay, if one giant superbrain isn't the right tool for these chaotic dynamic problems, then what is? Well, the researchers behind this idea say we should take a hint from nature. I mean, it's been solving complex problems for millions of years, right? And I love this analogy because it just clicks. The old way, the monolithic AI, it's like having one genius doctor trying to manage the entire hospital all by themselves. Super impressive, for sure, but they're going to be overwhelmed and miss stuff. The new idea, swarm learning, is completely different. It's like having a dedicated team of specialists, a cardiologist, a lung expert, a neurologist, all focused on one patient. They each do their own thing, but crucially, they talk to each other to build a complete picture. So here's how it actually works with a system they built called SahaNet. Step 1, you have these little specialized agents. Each one only gets a specific stream of data. So one agent is only looking at ventilation, another is just tracking the oxygen gradient. Step 2, each agent comes up with its own private forecast based on what it sees. Step 3, and this is the magic part, they share those forecasts with each other. And finally, step 4, a supervisor agent gathers all these different expert opinions and combines them into one super robust prediction. The real genius of this whole setup is how flexible it is. When something totally new and unexpected happens, you don't have to retrain some colossal model from the ground up. Nope. Instead, these little agents can just quickly change how they talk to each other, how they weigh each other's opinions. The whole system can basically reconfigure itself and adapt on the fly. Okay, so that all sounds amazing in theory. But does it actually work when the pressure is on? Well, the researchers decided to find out by putting it through the ultimate stress test, a simulated life-or-death medical emergency. So what they did was create a digital twin of a patient in the ICU. Then they threw a major crisis at it, a sudden severe drop in lung function, a lot like what you'd see with acute respiratory distress syndrome. The AI's job was simple but critical. Predict the patient's blood oxygen levels. Get it right, and you save a life. Get it wrong? Well, you get the idea. So the question was really straightforward. After this sudden, catastrophic change to the patient's body, which AI could get its bearings and start making accurate predictions again faster? Was it going to be the giant monolithic model or this nimble little team of specialists? And the results? Wow. Just look at this. They are absolutely stunning. The swarm model, SHA-net, it figured out the new normal and got back to making accurate forecasts in just 10 minutes. The giant monolithic model, it took 200 minutes. That is more than 3 hours. In an ICU, that's not just a long time, it's a lifetime. The swarm was literally 20 times faster. 20!
So what in the world does this all mean for the future of AI? Well, it kind of suggests that maybe, just maybe, we've been chasing the wrong kind of intelligence all along. All right, let's wrap this up with the key takeaways. First, these giant all-in-one AIs get bogged down by that curse of dimensionality in really dynamic situations. Second, remember, they're built to interpolate, not extrapolate. They can't handle things they've never seen before. But this new idea, swarm learning, takes a cue from nature, using small, specialized agents that all communicate, and we saw how this decentralized approach adapts just ridiculously faster to sudden shocks. So what's the big picture? The future of AI might not be one single superintelligence, but a whole ecosystem of different models working together.
And that leaves us with this one really big question to chew on. Is our whole quest for a single, super intelligent machine kind of misguided? What if the real future of intelligence doesn't look like one giant mind, but more like a beautiful, coordinated, and incredibly adaptive swarm?